Hello everyone, good afternoon. So, as we promised, we are going to record the lecture for this week. Alright, so we are going to start a new topics. This topic is for tree and binary tree. Alright, so far all the data structure we have been seen so far, they actually store only linear data, right? So for example, say we saw that all the data we saw, it was like in the form of list. Okay, it was a linear data, so we store them either in the array or in the linked list or doubly linked list or in the stack or queue. Okay, so these all the examples are in linear form. Okay, like a list. Okay, I mean, we scanned the list and we can traverse the list, okay, one by one. All right, now in this topic we are going to see a new form of data structure. Okay, so what about if we have information? Now instead of having the linear information, if we have a hierarchical information. Okay, for example, say example of hierarchical information could look like employee in an organization, employee hierarchy in an organization, or file system, okay, or network routing. So if we look at the employee hierarchy, if we can see that, let's say this is the employee hierarchy for our whole university system. Okay, so at the higher authority, we have president. So under president, there are a couple of posts. They work under president. Okay, so they are responsible to directly report to the president. And then there are a couple of other job posts under the VP academic affair. For example, say dean of business or dean of all dean, they directly report to VP. Okay, then for each dean, uh, then there are a couple of other job posts. Okay, so dean of engineering, we have chair of computer science, and we are at this level. So let's say faculty, we are going to actually, when we are going to report, we are going to directly report to the chair of our department. So chair of department is going to report to the dean of engineering, and dean is going to report to VP. And at the higher authority, we have president. So everyone, the VP and VP research and all VP vice president, they are going to report to president. So here you can see the hierarchical organization, a hierarchical structure. Okay, so another example is file system. All right, so in file systems, especially if you look at the Unix file system, you can see that for every user there is a user folder. Okay, let's see user folder. There is a folder for each user. For each user there is, let's see, document folder, and in document folder you can store multiple other folder. Okay, and in each folder there could be some file means in file you cannot have any more level after the file, but if you have a folder, inside the folder you can store a additional folder or a file. Okay, so that's how a file organization is also maintain the hierarchical structure. Okay, now what if we have this hierarchical structure? In that case we have to actually keep store of lot of information. That means the information of the ancestor and the information of the descendant. Okay, so in that case we are going to use a new data structure known as tree. Okay, so these data structure tree are used to store hierarchical data. All right, so first we are going to know some common term for tree data structure. Okay, all right, as we said in our last example, tree, we are going to use this data structure tree for where we have a hierarchical structure. Okay, so a tree looks like this. So first we are going to know all the terms related associated with the tree. Okay, all right. So in this tree you can see that there are a couple of circle and there are a couple of line, and lines are connecting this circle. Okay, so this circle, they are actually each entity of the tree. Okay, they are the each entity of the tree. So each of this circle or this entity, they are known as vertex or node. Okay, so they are known as node or vertex. So here we have total 13 node. Okay, so these each are different color. Each different color means different type of node, but all of the circles, they are the node here, and they are the main entity of the tree data structure. And this line, you can see that here is a line connecting two vertex, and these are the we can tell them these are the relationship between two node. Okay, but the main entity in the tree is the node or vertex. Okay, so first we are going to start from the root node. The top of the tree, in the top of the tree we are going to have one node. Okay, so the whole tree is going to start from that top node. So this node is known as root. Okay, all right. So this is known as root node, and every tree has only one root node. Okay, only one root. Okay, every tree has only one root. All right, now a node can have one or more child. Okay, so child means the node that are its immediate descendants. So for example 0, here you can see that this node has let's see a id 0, so it has the immediate descendant 1, 2 and 3. So they are known as the child node of root node. So 0, the node identified with 0 has 3 children, 1, 2 and 3. Okay, so each node can have one or more child. Okay, and also there could be some node that doesn't have any child. Okay, all right. So a node that doesn't have any child, they are known as leaf node. So in this example you can see that here there are a couple of node marked as green color. Okay, so here like 9, 15, 10, 12, 13, 7 and 8, they doesn't have any children. Okay, so if a node doesn't have any children, they are known as leaf node. Okay, so before that just think about a tree. Okay, so a tree is look like this. So a tree has a root and a tree has branch, and one branch can have multiple branch. Okay, now at the end of the branch we have some leaf. So a leaf means from the leaf there is not going to be any branch, but if there is a branch, if there is a wood, from one wood there could have been multiple branch. But when there is the leaf, leaf means that's the end of the branch. Okay, so we are going to use actually the same term for the real tree, for the tree data structure. Okay, so each tree is going to have one root. All right, so the root is also the node, but the root is a special node that doesn't have any parent. Okay, or ancestor. So but any other intermediate node are here marked as this red color. So 1, 2, 3, 4, 5, 6, 11, they are the intermediate node. So this node can have one or more than one children. Okay, so a node with one or more child, they are known as internal node. All right, but the node that doesn't have any child, you can consider them like the leaf. Okay, so a leaf means this is the end of the branch. So from a leaf there is not going to be any branch. So here also the leaf node means if a node doesn't have any child, this is the leaf node. Okay. Alright. So for example, here in this tree we have 13 node. So the 0 node is the root, and there are a couple of intermediate node that has one or more child, and the leaf node means that doesn't have any child. And the root node means the root node is going to may have one or more child, but root node doesn't have any parent, okay, or ancestor. So in this data structure we can see that node 0 or root node has 3 children, node 1 has 2 children, 4 and 5, 4 has 1 children, 9. Now 5 doesn't have any children, so this is the leaf node. So 2 has 6, 2 has 1 node, actually number 6, 6 has 3 node, 2 of them are leaf, 11 has 1 of them is leaf, and 3 has 2 children, both of them are leaf node. Okay. So this node has total 13 nodes. This tree has total 13 nodes. Now let's see the another component of tree is age. Okay, so each tree has the first component or all the entity, they are known as node. So the circles, they are known as node or vertex. So another component of this data structure is this line. You can see the line that is connecting two nodes. Okay, they are known as edge. Okay, so each of the line, each of the edge that are or link, you can say link that are connecting two nodes, they are known as edge. Okay, so these edge are links, they are going to be connected, actually they are going to connect from parent to child. Okay, so for example here node 1 is the parent, and 4 and 5 are the children of node 1. Okay, so each node in the tree will have exactly one parent. So that's very important. Each node is going to have only one parent. I mean, in real life we can have generally we have two parents, but for tree data structure each node is going to have only one parent. For example, 9 has one parent, 4 has one parent, 1, and 1 has one parent, root node. So in a tree, if you have n node, there is going to be exactly n minus 1 link. So you can count the number of edge here. So we have here 13 node, and the number of edge or number of link is here 12. Okay. So now we are going to know some of other nomenclature of the tree data structure. So these are, one of them is depth and one of them is height. Okay, so the depth of the node is the number of edges on the path from the root node. Okay, so consider any node. The depth of a node is the number of edges on the path from the root node. So for example here if you consider the node 10, okay, so from 10 to root node we have how many number of path? 1, 2 and 3. Okay, so from the node to the root node, what is the length of number of path? What is the length of the, what is the number of edges from root to that node? This is known as the depth. So for node 10 the depth is 1, 2 and 3. Okay, so it has depth 3. Now for node 13 the depth is 1, 2, 3 and 4. So node 13 has depth 4 and node 3 has node 10 has depth 3. Okay, so what about the node 9? So node 9 has 1, 2, 3. So node 9 has also depth 3. And here you can see that they are actually in the same level, so they are actually in the same depth. Okay, so node 9, 10, 11, 12, all of them has depth 3. Okay, so here 4, 5, 6, 7 and 8, all of them are in depth 2. Okay, you can check that 1 and 2, so depth 2. So 1 and 2, it has depth 2, so all of them are with depth 2. These are depth 3, and this node, the last node, uh, the node 13 is in depth 4, and 1, 2, 3, they are of depth 1. Okay, so the depth of root is 0. Okay, so the distance from, the distant path distance from 0 to 0 is uh, root node to root node is 0. Okay, so the depth of root is 0. All right, now the another term is known as height. Okay, so the height of the node is the number of edges on the longest path from the node to the leaf node. So the height of the root node 4, the height of the root node is 4, and the longest path to a leaf node is 4 edges long. So here the height means you are going to consider a node, and from that node you are going to find the longest path from the leaf node. Okay, so for example, if we consider the root node, let me change the color. So let's see, if you consider the root node, starting from the root node to the longest distance from the root node to the leaf node is 4. 1, 2, 3 and 4. Okay, so the height of the root node is 4. Okay, now let's consider the node 1. All right, so the node 1, starting from the node 1, the distance from node 1 to the longest leaf node is 1 to 4 and 4 to 9. Okay, so 2. So the height of height of node 1 is 2. Okay, and for each leaf node their height is 0. Okay, all right, now let's look at this example. Here we can consider each of we can consider the tree, we can visualize the tree level by level. So if we visualize the tree level by level, it is going to be easy to find the depth of each node. Okay, by level means at the first level we have the root node, so in the second level we have all the children of the root node. Now root node has children 1, 2, 3. Okay, now in the third level, so in the next level we are going to have the children of all the children of the root node. So that means the root node has 1, 2, 3 children, and at the next level we are going to have the node who are the children of node 1, 2 and 3. So this is going to be 4, 5, 6, 7 and 8. Okay, so you can see that all at the root level the depth is of the root node is 0. So all the children of root node, direct children of the root node, they have the level 1. Okay, level 1 means depth 1. Okay, and then we have 4, 5, 6, 7, 8. They are the children of root. So children of 1, 2, 3, so they are in the level 2. So both, all of them, 4, 5, 6, 7 and 8, they have depth 2. Then in the third level we have 9, 10, 11 and 12. Okay, they are the children of them, and 9, 10, 11 and 12, okay, all of them has depth 3. Okay, so it's just that, think about like level by level, and the number of level is the is their depth. Okay, and at the final level we have 13, and 13 has the depth 4. Okay, so depth of the node is the number of edges from the on the path from the root node, and the height of a node is the number of edges on the longest path from the node to a leaf node. Okay, so let's find the height of each of the node. Okay, so here the height of each leaf node is 0. Okay, so each leaf node has height 0. So here you can see 5, 7, 8, 9, 10, 12 and 13. So 5, so 5 will have height 0, 5, 7, 8, 9, 10, 12 and 13. They all of have height 0. Okay, all right. So how about this node? So node 11 will have height 1. So so height is the longest path from the node to the leaf node. So node 11 will have height 1. Okay, the distance from the leaf node, the longest distance from the leaf node is 1. So node 4 has distance, node 4 has height 1. So node 4 has also height 1. So node 3 has, look at node 3, node 3 has also height 1, and node 1 has 1 and 2. So here the distance from leaf node 5 is 1, but the longest distance from the node to the leaf node is 2. Okay, so node 1 has the height 2. All right, so one interesting structure of the tree. So if you look at the tree, so each node has couple of children. Each node can have couple of children, and starting from that node, the children node can have children. Okay, and that's how. So just look at all the children here. So the data structure of the tree actually looks like this. So this is the root node. Each the root node has actually, as a children, they have couple of subtree. Okay, so look at these children of the root node. Now root node has 2, 3 and 4. Now if the node 2, if I consider the node 2 as a root node, the node 2 also we can visualize that also like as a tree. Okay, so starting from the node 2, if we consider node 2 as a root node, so that is also like a tree. Okay, that is also a tree. So starting from the node 3, if we consider node 3 as a root node, that is also has the same data structure like as a tree. Okay, same here. Okay, so we can say that a root node has children, and all of the children can be also considered like as a subtree. So this node has 3 subtree. Okay, again starting from node 2, we have 5 and 6. So considering them, this one is also a tree. Okay, so this one is also a tree, but only one node. So this one starting from 7, this is also a tree. Okay, so the data structure of tree is, it's a recursive structure. Okay, so here starting from one node, it can have couple of subtree. So here each subtree also contains couple of other subtree. Okay, and the data structure, the whole data structure, and in the last discussion what we were talking about, the data structure of tree is the same. Each subtree has the same data structure as the tree structure. Okay, so we can say that the subtree have the similar recursive structure. All right, So the height of a node in the tree is one more than the maximum of the height of its immediate child node. So we are going to see a couple of more example, and we'll see you in the next video segment.